In this video, I'm going to be working the second review for Algebra 2 Unit 7. And this was also an online quiz for my class one day when I was out. So the first one is talking about let f be the polynomial function defined below. And the first one is one we're going to want to work without using a calculator. And the point here is that you want to be able to work this one without a calculator, right? Because you might be asked to do it without a calculator, say on a test or something. So, if they're saying x equals 2i is a root of the polynomial f, find the other three roots without using a calculator. Alright. Well, and the hint is that synthetic division works with imaginary numbers, which is not something that we've done yet up to this point. So what we're going to do is we're going to say, alright, we're dividing x to the 4 plus x to the 3 minus 2x to the 2 plus 4x minus 24 by x equals 2i. Okay, and so that's going to be 1, 1, negative 2, positive 4, and negative 24. Okay, we drop the first one down, we multiply, and we add. Oh, no. Not sure what happened there. Okay, 1 plus 2i. Then when I multiply this in, I'm going to have 1 times 2i is going to be 2i. And then 2i times 2i is 4i squared. That's going to be negative 4. Add this together, I'll get negative 6 plus 2i. And when I multiply these things together, I'll get a negative 12i. And 2i times 2i is negative 4 again. Okay, so then when I add these together, I'll get negative 12i. And negative 12i times 2i is going to be positive 24. There we go. And that'll add to 0. Okay, so we see that x equals 2i is a root of this polynomial. Now the trick here is if we know x equals 2i is a root of the polynomial, we know x equals negative 2i is also a root of the polynomial. And so we're going to drop this down and do the exact same thing. But much like in the last unit when we did this with the square root, the second time we do it, it's a lot easier. So I multiply 1 times negative 2i, and I get negative 2i, and what do you know? Okay, they cancel off. Okay, 1 times negative 2i is negative 2i, and then again they cancel off. And negative 6 times negative 2i, that's going to be positive 12i, and then that's going to add to 0 again. And so we see that x equals negative 2i is also a root of f. Okay, and what we've got is okay, x equals 2i. We saw that when we divided in the first thing, we got 0. X equals negative 2i. We saw that when we plugged in x equals negative 2i and got 0 out of the quotient. And now what we're left with is 1x squared plus x minus 6. And if we want all the roots of f, we're going to need to figure out where this thing equals 0. We're going to factor, because positive 3 and negative 2 are going to be two numbers that multiply to negative 6 and add to positive 1. I'll say, alright, that's going to be happening anytime that x is equal to negative 3 or when x is equal to positive 2. Okay, that was part A. Looks like I'm going to need a calculator for the rest of them, so I'm going to need to bring that in. Alright, so I'm going to need to plug this polynomial into the calculator so I can graph it and figure out for what values of x is f of x less than 0. Okay, I'm going to need to clear that out. Okay, not sure why it won't clear. Hold on. Okay, and so I'm pressing x to the 4 plus x to the 3 minus 2x squared plus 4x minus 24. Okay, I'm graphing this thing. And I'm seeing those zeros that I already knew were on there since we just worked that problem before. And so, alright, so it looks like between these two zeros, f of x is less than 0 because y is below the x-axis, right? These are places where y is negative, and f of x, that's just talking about the y-coordinate on the graph. So we're going to say this is less than 0 when x is between negative 3 and positive 2. And it's going to be strictly less for both of them because it's where f of x is less than 0. Now we could calculate the 0, right? Somewhere between -4 and -2. And it would tell us that the... Oh, whoops. Oh, yeah, give it a guess. Yeah, and it would tell us that the 0 is right at x equals -3. Okay, but we already knew that from the work that we did in the last part of the problem. Okay, and then what is the absolute minimum value of f? Okay, so that's going to be like, what's the value, what's the y value at the very bottom point on this graph? So we're going to need to be able to see a little bit more. So we're going to go over here to window, and we're going to ask for a little bit more negativity in y, right? Let's go down to, I don't know how far I need to go down, so I'm just going to do -50, but we don't really need any positive area in y, so maybe I'll do that. Okay, yeah, so I'm looking for this y coordinate right there if they're talking about the minimum value of f. Because if it's a value of f that I'm looking for, it's a y coordinate. So I'm going to calculate a minimum. That's option 3. Left bound, I gotta go scroll to the left of it, and you can type in a number that you know is to the left of the minimum, or you can just scroll on the graph until it goes to the left of the minimum. You can scroll to the right, or you could type in a number. You could type in 0 because we know that the y-axis is on the right of the minimum. Okay, give it a guess, and all right, x equals -1.691 that's the x value where it's happening, but I'm looking for the value of f. So I want y equals -33.142 or -33.141, right? We round to 3 decimals in this class when our answer is coming from the calculator. Okay, so yeah, that's all for that one. All right, now the next one's just going to be more calculator stuff, and so I already typed in g of x for you. I don't think you need to watch me typing that in. And it says the graph of g has one negative real root. What's the value of the root? All right, now having just worked the previous problem, we're going to need to set the window back to the standard window, so we're going to zoom to standard. That's number 6. And then look and see what we can find. All right. Has one negative real root. Okay, so it's talking about this right here. Okay, so we need to calculate the 0. We'll scroll to the left of the 0. We'll go to the right of the 0. Give it a guess. And there we've got it. Okay, the negative root of g is x equals -1.343. Or -1.342 would have given you the credit on the online quiz at least. Okay, what x value does g have a local maximum? Okay, so we're looking for the x coordinate right here. So we're going to calculate a maximum. It looks like it's between x equals 1 and x equals 3. So I'm going to type in 1 to 3. But you could scroll if you like. Okay, and give it a guess. And then the maximum is going to happen at x equals 1.869 or 1.868. And for where g is increasing, that's going to be from here to there, okay, where as I move left to right, the graph goes up. So I've got the x-coordinate of the maximum, so that's going to be the kind of the right edge of my interval. And I just need the left edge, so I'm going to calculate the minimum. Okay. It's between -2 and 0, so I'm going to type in -2 and 0. Say, all right, x is between -0.535 and 1.869. And where is g both positive and decreasing? Okay. So what we're looking for is, where g is decreasing down through here and down there. Wait, it's okay, positive and increasing. Okay, I was going to say there's two places where it's positive and decreasing, right? It's through here. Okay, where the graph's above the x-axis, that's positive, and decreasing is where as I move left to right, the graph goes down. That happens twice. Okay, so we're looking for positive and increasing. That's going to be from here to the maximum. So I need to compute that 0 right there. So I'm going to calculate a 0 that's between x equals 0 and x equals 1. And I'll get x equals 0.529. Oh, whoops, I didn't even see that that was not visible. Okay, so from 0.529 is less than the relative maximum, which happened at 1.869. All right. This next one, this one won't need a calculator or anything, so I'm just going to solve this one by hand, because this is one we're going to need to be able to solve by hand. So we're going to start by setting this thing equal to 0, because that's what we're going to have to do with anything that has, more than 1 degree of x in it. So we're going to say 3x to the 4. I'm going to zoom this in a little bit. So I'm setting it equal to 0, and I'm saying 3x to the 4. I'm going to subtract 3x to the 3 from both sides. I still have 48x to the 2, and I'm going to subtract 48x, and that will be equal to 0. Okay, so I've set it equal to 0. That's the first step. Now I'm going to try to factor it, and this thing looks really factorable. And I've got 4 terms, so I should try to do group and factor. But maybe actually before I do that, I should always remember, hey, I don't always remember, but you should, to always look for a greatest common factor. Okay, and I see that 48 is divisible by 3, and everything has at least one power of x in it, so I'm going to factor out a 3 and an x. And I'll be left with x to the third minus x to the 2 plus 16x minus 16. Now the thing inside those square brackets, that's what I'm going to group and factor. That'll be a little bit easier. So what's common to these is going to be x squared, and I'm left with an x minus 1. And then 16x minus 16, those just have the 16 in common. So I'll be left with an x minus 1 there. And this is going well, right? We can factor out the x minus 1. And then I'm left with x squared plus 16. I just move over here and just look at this equation for a second. So if the product of these three things is equal to 0, then either 3x is equal to 0, or x minus 1 is equal to 0, or x squared plus 16 is equal to 0. And if 3x is equal to 0, okay, that's going to mean that x has to equal 0. And if x minus 1 is 0, that's going to only happen when x is 1. But this one, I'm going to have to do a little bit more solving. Because I only have one power of x in this equation, I can solve at it directly. I can say x squared equals negative 16. And then I'm going to take the square root of both sides, and I need to not forget the plus minus when I take the square root of both sides of an equation. The square root of negative 16, that's going to be 4 times I. So I've got plus or minus 4i. Okay, so that's giving me x equals 4i and x equals negative 4i, and these are my 4 solutions to that equation. Right, yeah, find all solutions, and yeah, it said it was looking for 4, it's a 4th degree polynomial, that's great. Right, now this last one's got something a little bit different, I haven't seen in a while. So I'm kind of like some applied geometry. So we've got the graph of h of x is shown below. Let p and q represent the points at which h has a local minimum. Okay, so we can see those points. It looks like x equals negative 1 is one of them. And yeah, because we see that's a double root on the graph of h. And then q is this other point where we're having a local minimum, which looks a whole lot like x equals 3 to me. But we don't know that for sure, so we're going to graph it on the calculator and make sure, right? We don't know this in general. Maybe we need calculus to know that. So we've graphed it. We're going to calculate the minimum. I think I have worked this problem before, and this one it did turn out to have integers, which is kind of a shame because you need to be able to work with possibly decimals in this situation. So I'm going to calculate, not the 0, I want the minimum. Okay, so I'm going to need, I know that x equals -1 is one of the minimums. So p is going to be, the coordinates of p will be x equals -1 and y equals 0. But q, that'll be something I need to solve for using the calculator. So I'm computing the minimum. The left bound, yeah, we're to the left of the minimum. Right bound, we're just going to scroll until we go to the right of it. Okay, we've gone to the right of the minimum. Okay, that would be a good guess. Okay, and we get 3 point, bunch of zeros and 1. Okay, that means 3. Okay, the calculator, you know, it's not perfect. It's got a little bit of round off error. None of us are perfect, and so you take that to mean 3. Okay, so we're going to say x equals 3 and y equals -8. All right, now had these been decimal numbers that weren't exact, okay, and I know that there was a bunch of decimals on 3, but it meant to be exact, and kind of like, I think we've seen already in this class where it means 0 and it said something times like 10 to the -12 or something, and it, you know, that's just its way of saying 0, and then this is just its way of saying 3. Okay, had there been, you know, more interesting decimals, you would need to copy all of the ones that you had available to you until like the very last step, right? Because we don't want to just like round to 3 decimals and then use a rounded number to compute another number later in the problem, because we could have error in the last decimal. Okay, now I'm going to be saying, all right, first thing I'm going to need to compute the slope. So slope is going to be just y2 would be y of q minus y1 would be y of point p divided by x2 minus x1. Okay. And that's going to be the y coordinate of q minus the y coordinate of p divided by the x coordinate of q minus the x coordinate of p. Okay, so that's -8 divided by 4 is equal to -2. And then to compute b, I'm going to go, okay, well, I've got y equals mx plus b. And, well, I know that 2 points on this line are p and q. I could choose either one of them to plug in. I think I might just choose p, though, because I'm a little more certain about that, right? We know that that's going to correspond to that double root on the graph of h. So I'm going to plug in y equals 0, m equals -2, and x is equal to 3. No, pardon me. X is equal to -1 because we're using point P. Okay, and then plus b, and we'll solve for b that way. Okay, so 0 equals +2 plus b, and then b will equal -2. Okay, so m and b are both -2, and the equation of the line is y equals -2x minus 2. Okay, is that all of them? Yeah, that's going to be all of them. So thanks for watching. This was a good selection of problems that use the calculator that are pretty similar to the types of problems you might be asked on the free response section of an upcoming test. So yeah, good for you for watching.